and altitudes and perpendicular bisectors, then we're going to look at something that kind of relates to this a little bit, especially with the perpendicular bisector part. We're going to be starting to look at what are called chords. So what a chord is, I've got a definition here, a line segment that's going to be joining 2 points on a circle. So they've given you kind of a nice little diagram there to work with. One of the chords that is probably the most commonly known is what's called the diameter of the circle, because all that is the chord that specifically goes through the center of the circle. So this is a chord because all a chord is any line segment that connects any 2 points on a circle. So if it goes through the center, it's still a line segment that's connecting 2 points. It's just a really specific chord then. So what we're going to be looking at with chords, not necessarily the diameter, but just some line segment, is how they relate to what we just talked about. So here I put a couple different things down below. It says the right or perpendicular bisector. You can kind of interchange those two designators. Bisector of a chord, it's going to pass through the center of the circle. So this is a guaranteed thing that happens. It's a pretty cool little property that we're going to try to use to our advantage. And that any two right bisectors or perpendicular bisectors coming from different chords, they are going to intersect exactly in the center of the circle. Now there's some reasoning why. I'm not going to get into like a lot of depth here, but I'll kind of do it with a diagram so you can kind of see it, and then I'll decide whether I want to put up the explanation as to why this works afterwards. Okay, let's try the example. This says determine the center of the circle that's going to pass through these points. So how we can do that is by creating some chords. So what I could do is, let's say, make this chord. So I've already kind of drawn in A, B, and C. I can make the chord that's going from B to C. Okay, so there's my chord. And I could also make this chord that's going from, let's say, A to B. I could also make the one going from A to C, but I'm just going to kind of stick to these two just right now. And then I'll start filling more stuff in when we get more information. So this is my plan then. In order to determine the center of the circle, what I'm going to do is this chord, I am going to take its right bisector, which is the same thing as a perpendicular bisector. So using the same process that we did from the stuff from triangles, what I need to do is bisect this. So I need to find its midpoint. I need to find the slope of this line segment, and I want to create a line that will be perpendicular to it. So somewhere here is going to be its midpoint, and I'm going to try to create some sort of line that will be perpendicular to BC. And then that should be going through the center of the circle somewhere. And then I will do the exact same process over here. Between A and B, I am going to find the midpoint somewhere over here. I am then going to find the slope AB so that I could find its perpendicular slope, the negative reciprocal, so that I can find the right bisector that will be going also through the center of the circle, and where those two meet will be exactly at the center. So we've got a bunch of steps to go through. So the first thing that I am going to do is I'm going to find the perpendicular bisector or right bisector, depending on what you want to use. And let's do of AB. Let's do this one first. Okay. So if I follow the steps that we did in the previous lesson, step number 1, what I'm going to do is get the midpoint of AB. So I'm going to use my notation, capital M, subscript AB. So the midpoint here is going to be, I'm going to add the x's together. That's a 16. I'm going to divide it by 2. So that's an 8. I'm going to add the y's together, 10 and 6. That's also a 16, so divide by 2. Okay, the midpoint should be at 8, 8. So let's see, 8. Okay, so right here, this is the midpoint of AB. Okay. What I need now is the slope. So step 2, I'm going to do little m of AB. Okay, and then like what we were doing in class, I'm just going to put some placeholders for the y2 minus y1 over x2 minus x1, and then we'll put in our information. So let's do this way. So let's do y2 minus y1 over x2 minus x1. Okay, so what I'm going to get here is a 4 over negative 8, so negative 1/2. Step 3, what I'm going to need is the perpendicular slope for AB. So you write it like that, or I've seen some people write it like that. It really doesn't really matter. But what I'm going to do here is then take the negative reciprocal, so flip that and change the sign. So that's going to be the slope that I'm going to want. And then step 4, let's get the y-intercept. So if I do y equals mx plus b, we now have the slope we're going to use. It's going to be a 2. The x and y that we're going to plug in are going to be from the only point that I know is on this, which is the midpoint. So I'm going to plug in 8. So I've got 8 equals 16 plus b, so let's move that to the other side. I've got b being a negative 8, and then I can make the equation. So this is going to be y equals slope to x minus b, or minus the 8 that we have there. Okay, so this is the equation of the line that I want here. Okay, so that means that if I were to draw this in, it's a little bit off the scale. So down here at negative 8 would be the y-intercept, and it's coming up with a slope of 2. So what I could just do is just draw in a slope of 2. So go down and across, down 2, across, down 2, across, down 2, across, and so on. So this is the perpendicular bisector. Okay, of AB. So that's going through the center of the circle. I don't know exactly which one of these is the center yet, but it's going through it. So what I could then do is exactly the same thing. So let's do the perpendicular bisector of BC, and we'll follow the same steps. So step 1, I need to know midpoint BC. Okay, so here, let's use B and C. I'll add the x's together, 4 and 0, divide by 2, so 2. Add the y's together, 10 and 2, that's a 12, divide by 2, 6. So at 2, 6 is the midpoint, so 2, 6 right here. There we go, that's midpoint BC. And I want to do exactly the same thing. I need the slope of BC so that I can get the perpendicular slope that's going to come through here somewhere. So step 2, slope of BC. Let's just put in the actual slope and have it over here. It is a 2. You guys can already calculate that. You have an example here. Step 3, let's take the perpendicular slope of BC. So that's going to be a negative 1 over 2. So this is the slope we want. Step 4, let's put in the pieces to get the y-intercept. Y equals mx plus b. We've got a slope of negative 1/2. I'm going to plug in my point in order to find b. So the point I'm plugging in is the only one that I know that's going to be on this line right now, which is the midpoint. So x being a 2, y being a 6. So I've got 6 equals negative 1 plus b. So there we go. B is a 7. Which means we can make the equation. This is y equals slope is a 2, x, and then y-intercept 7. Nope, not a 2. I need the actual, oh, it's not even a good eraser. Negative 1 over 2. There we go. Gotta be careful. Maybe I should point this stuff out even to myself. These are the ones that I want. That slope, that y-intercept, yep. That slope, that y-intercept, yep. Okay, so let's draw this thing in. So this is going to be the line that has the y-intercept at 7 and a slope of negative 1 over 2, which means I would go down and then across, down and then across. Okay, so it's going to look something like this. which means from the diagram, well, I can kind of see where they meet right here. That's the center of the circle, so I kind of know where it is right now. But let's say I didn't actually have this diagram to see what was going on. Then all I would need to do is use something we did way back in the very first unit, which is to solve a system. So if I want to know where this line and this line meet, then that's my last step in this process. I'm going to solve the system, and my system is the one that has this line, y equals 2x minus 8, and y equals negative 1 over 2x plus 7. Okay. And then we can solve it using whatever we did in that first unit. So substitution, elimination, up to you. The way that it's written right now, where the y's are already isolated, let's just use substitution. So I could say something like this, 2x minus 8 is equal to y, and this is also equal to y, so negative 1 over 2x plus 7. Okay, so these are equal, and I need to solve for x. Notice there's only one variable in there, x, so we need to get things over to one side for our x's to get isolated, and then move all the constants over the other side. If you don't like working with a fraction, because there's that 2 there, then let's just kind of wipe out that denominator by multiplying everything through by 2. So I could do this. There, the denominator's gone, no fractions if you hate those. So let's move all the x's over, let's say, to this side. So I already have 4x here, let's move this one over. I already have a 14 on this side, let's move the negative 16 over. Okay, and then collect. X is going to be a 6. So I know that this is where the center of the circle is. It's going to be when x is a 6. And if I want to get the y coordinate, which I'm going to need because it's a full point, then I can plug that into either one of these, because this is where both of them have the same coordinate. So let's say they use the first one, equation number 1, equation number 2. Equation number 1 is then y equals 2x minus 8. We said that that is going to be a 6. So y is going to be a 12 minus 8. So therefore, the center of the circle is at 6, 4. Done. And if you check what we did with our little diagram here, that's at 6, 4. So we're good. So just kind of recapping, what we've got then here is our little application that we can use with perpendicular bisectors, using the fact that chords we can get perpendicular bisectors of, and we know that they are guaranteed to go through the center of the circle. So if I ever want to find the center of the circle, just take any two of these and see where the perpendicular bisectors meet. And that also would have worked if we had here. The reason I didn't want to choose A to C is because that one's actually a diameter. It's automatically going through. This one's a little bit easier to see, but it's still true.